Let's take one more application. A diazo coupling reaction on aniline. How it proceeds, let us see. On benzene, actually diazo coupling is a failure reaction. Diazonium salt N2 plus Cl minus if you add. So the reaction is not taking place, though this is an electrophile. Actually the benzene undergoes electrophilic substitution reactions, but this electrophile is not a good electrophile. It is said to be a weak or poor electrophile because of the resonance stabilization of the NN with the benzene. Sometimes the plus charge will be in the molecular form or in the form of a resonance into the ring. So therefore the plus is not a strong plus like a nitro plus and so on. So the ordinary benzene generally fails, but if you have a amino group, that's one of these better activating group, or phenol. OH is also a strong activating, that too in the basic medium. Phenol in the basic medium readily undergoes this reaction. Now the aniline undergoes this reaction fairly, so you will get a diazo coupling at the para position, leading to that we explained already. There is a steric hindrance, therefore the reaction takes place at para. This is called aniline yellow. A diazonium chloride coupling at the para position of aniline. Aniline yellow is formed as a dye formation. However, now this aniline, let us take a slight extension. The amino group has two methyl groups. Then what happens? Then also the reaction takes place wonderfully, because the lone pair is activating, right, to get ortho, para, ortho minus. This methyls will not have any problem. The lone pair still can make a double bond and make minus and minus and minus. This methyls in fact will have a plus I effect, so increase the reactivity but not decrease. And the reaction is taking place on the other end of the molecule. So these methyls will not have any problem or will not stop any percentage or decrease any percentage of this product format. Excellent reaction takes place. Now see the extension of this reaction. An aniline containing a two methyls on the ortho position. These methyls also will not hinder the reaction diazonium chloride when I add N2 plus Cl. Excellent reaction taking place. The electrophile will attack here. So the still the lone pair on the nitrogen will be activating ortho, ortho, para. Anyhow ortho already blocked, that is filled. So therefore it goes to the para, and the groups that side will not have any hindrance. And moreover the methyl is activating groups plus I, so therefore we have a plus point, not the any discriminating type, or the reaction subsiding conditions are not there. So therefore reaction takes place. Therefore what I would like to say is, this is a weak electrophile. So ordinary benzene will not react. When a strong activating group like amino or OH group in phenol, that is in basic medium, activating groups are there, reaction takes place. The two methyl groups on nitrogen will not have any problem, reaction taking place. Two methyls on ortho and ortho is also no problem, reaction taking place. Now the last explanation, see here, a nitrogen containing two methyl and benzene also having the two methyl. Now the reaction, if you are proposing, the reaction is failing to give the reaction. It's not taking place. Why it is not taking place means, if somebody says the para attacking is having a steric hindrance of these four groups, means it's not actually correct, because the four groups creating steric hindrance that side on the top side, the attacking the group is at para position. Where is the steric hindrance? Okay, that's not correct explanation. But one word answer, it is due to the steric hindrance is right answer. How it is right means, because of the steric hindrance between these two methyl groups, there is a steric hindrance between the methyls, isn't it? There is a steric hindrance. So therefore what happens, the nitrogen, if I want to show the plasma effect, if at all the nitrogen want to show the plasma effect, the nitrogen benzene should make a double bond, right? Then only the plus M effect come into the force. A double bond means the plane of the nitrogen, the plane of the benzene should come into the same plane. Then p electrons will come onto the parallel each other, then a pi bond formation. In order to show the plus M effect of the nitrogen, the lone pair, that is when nitrogen undergoes sp2 hybridization, this carbon is already sp2, the plane of the nitrogen and the plane of this carbon, this sp2 carbon, center junction carbon, should come into the same plane. Both are trigonal planar, but these two trigonal planars should come into the same plane, so that a pi bond should form between the nitrogen and the carbon of the benzene. Then the plus M effect will come into the force, thereby ortho para will become rich in minus and the group will attack at the para, right? But because of this steric hindrance between the side by, that is ortho-ortho groups and the n groups, the two planes of the nitrogen plane and the benzene plane rotate perpendicular to each other. Because of the steric hindrance of the two methyl groups, they rotate perpendicular to each other. Then the pi bond formation between the nitrogen and the methyl is not possible, because pi bond forms when the planes are in the same plane and the clouds come into the parallel to each other, then only they make. So the pi bond, that is the trigonal planarity of this one and trigonal planarity of this one, will be perpendicular to each other. So the N with the two methyls cannot show, or the lone pair on the N cannot show the plus M effect with the benzene. When once the plus M is stopped, okay, the nitrogen originally through the bond, it has originally minus I effect. That will become dominating phenomena. Actually, amino group shows two effects, plus M effect, minus I effect, but this is active. So strong is mesomeric effect, inductive is recessive. But in this particular condition, when plus M is not working, minus I starts working, and it will become, instead of activating, it's a deactivating function. Then the reaction is, that's why failing. So one word answer, the nitrogen with two methyls and the benzene with two methyls create steric hindrance, therefore no reaction. Absolutely right. But how it influences the steric hindrance between the two, that is this methyl groups, steric hindrance, rotate the plane of the nitrogen and the benzene perpendicular to each other, so that there is no pi bond formation. When there is no pi bond formation, no plus M effect, and consequently ring activating property is not taking place, and this poor electrophile cannot attack on the benzene. Under that condition, therefore the Diazo coupling reaction is not taking place. Explanation is likely in an indirect way or little complicated, but this is one of the excellent application for this steric hindrance, the explanation. Thank you.